In this video, we're going to take a look at properties of parallelograms, rhombi, rectangles, and then, of course, squares. There's a lot of properties, but I also think they're pretty intuitive. So let's get started. This is probably going to span a couple videos. So first of all, let's fill in a Venn diagram with the words kite, trapezoid, parallelogram, rectangle, rhombus, and square. So remember, what a Venn diagram does is it shows the relationship between different sets or groups. So this outside circle represents the set of all quadrilaterals. If you notice, we have two circles that are completely within the quadrilateral set, but totally independent. Like they're not overlapping, they're not touching, they're separate circles. And then we have one circle or oval here with then two other circles or ovals inside them and a bit of overlap. So when we fill this in, we want to think about the relationship. So for example, parallelograms can be used to describe any type of quadrilateral that has two sets of parallel sides. Well, that actually also applies to rhombus, square, and rectangle. Oops, I spelled rhombus wrong. So that means parallelogram is here, because there are other types of quadrilaterals that fall within the parallelogram subset. So that means if we look at the words kite and trapezoid, they are in these two sets here, because a kite and a trapezoid don't have any common features, nor are there any other specific types of quadrilaterals that share their features but are distinct from them. So under the parallelogram umbrella here, we have rectangle, rhombus, and square. Now when we look at this, remember, a rectangle is equiangular, and a rhombus is equilateral, and a square is both equiangular and equilateral. So that means rectangle goes in one square, rhombus goes in another, circle, and then square is actually the intersection or overlap of rectangle and rhombus. So square shares all the features of rectangle, all the features of rhombus, and all of those shapes share all the features of parallelogram. And that's actually going to kind of get us in the mindset for these parallelogram properties that we're going to take a look at today, because anything that applies to a parallelogram would also apply to a rectangle and a rhombus. Anything that applies to a rectangle applies to a square, but not a rhombus. And then vice versa with rhombus and square. So we're going to investigate these properties. And the first thing we're going to do is we're going to create a parallelogram on the grid next. Okay, so you are going to need a ruler, like a double-edged straight edge, and we're going to need a protractor to do some measuring. So if we take a look at this, we are going to first draw using the horizontal lines, and mine aren't going to be so great, but draw two lines that are, they want them 6 centimeters apart roughly, but if you're a little closer, that's okay. And then they want you to use your ruler, your double-edged straight edge. So put it somewhere in the middle and slant it and turn it. And then holding your straight edge straight, trace both sides of your straight edge. So you should get something like this. This part in the middle should be your ruler. You should trace one edge and the other edge. And then we're going to name our vertices L, O, V, and E. So first we're going to look at the opposite angles, okay? So opposite angles, right, would be looking at this angle and this angle, okay? So I want you to take a minute and I want you to measure them with your protractor. And then you would also take a look at these angles and these angles, okay? So compare a pair of opposite angles using your protractor. You should come out that they are congruent. Again, I do want you to confirm that. Pause the video, use your protractor, set it up, make sure that they are congruent, okay? And the other thing we want to look, okay, so we're going to fill in that conjecture. So the parallelogram opposite angles conjecture says the opposite angles of a parallelogram are congruent. And now we want to look at the consecutive angles, and we did look at consecutive angles in a trapezoid. Remember, we looked at the consecutive base angles. So now we're going to look at consecutive angles. Now you already have these angles measured, So what I want us to look at is look at this angle and this angle, and I want you to find the sum, and then go ahead, you can do this angle and this angle, and then this angle and this angle, and this angle and this angle. So you're going to add the measure of angle L and the measure of angle O, the measure of angle O, and the measure of angle V, the measure of angle V, and the measure of angle E, and the measure of angle E with the measure of angle L. So if you look at all those different sums, again, you should already have them measured, should be our beautiful magic number, 180 degrees. So for some reason, this is wrong. This should be consecutive. So the parallelogram consecutive angles conjecture says the consecutive angles of a parallelogram are supplementary. So now, let's use those conjectures to find some missing measurements. So we have ABCD as a parallelogram, and we want to find A, B, and C. So I just want you to notice how to measure or to read this diagram. See how this arc goes all the way from here to here, and it's labeled 68. That means this is angle A here, or angle DAC or DAB. That's 68 degrees. But see how this arc only goes from here to here? That would be angle ABD, okay, not angle ABC. ABC is this angle, the bigger angle. ABD is the smaller of the two. So just so you know, that's how you read that. Okay, so let's just remember some of our conjectures. So the parallelogram opposite angles says that the opposite angles are congruent. So for example, if we know this angle is 68 degrees, then this angle C must also be 68. So now part of angle C is 27, this part, and A is this piece. So that means 27 plus A must be equal to 68. So if I solve that and subtract 28, I get A is 41 degrees. So that's going to help me find A. The other thing that is going to help me is that we know that the consecutive angles are supplementary. So what's that going to tell me is that this angle A plus this angle, angle B, is going to be 180 degrees. So that means 68 plus, okay, this is 26 plus this little angle here. We're going to label that X. That has to equal 180 degrees. So when I add those, 894. That means that little piece is 86. So that's going to help us. I'm going to do some labeling here. This is 41. This is 86. And that's going to help us because I have C right here. So now what I want you to notice is this makes a triangle, right? So we can use our triangle sum conjecture, which says the sum of the angles in a triangle is going to add up to 180. So that means C plus 41 plus 180, excuse me, plus 86 isn't 180. So C is 53 degrees. Okay, so then how are we going to find B? Well, so again, finding C, notice this is a vertical angle, so that's going to be 53 degrees. And then we have another little, we could do a couple different things here. I want to show you a couple different opportunities. So one of the things I want you to remember is that the angles in a parallelogram, or the sides of a parallelogram, right, are parallel. So that means this segment and this segment are parallel. So notice this diagonal here is acting as a transversal, so we have our very, very famous alternate interior angles. These angles are alternate interior. But then we have another set of alternate interior angles. This, oops, didn't change color. This one and this one here. So that's going to help us because this right here is going to be 86. Remember, we found that. And its alternate interior to be, so then that's also 86. So step 4 says, describe how to use the two conjectures you just made to find all of the angles in a parallelogram with only one angle measure given. So again, let's just think about this. Here's our parallelogram. If we know one of the angles, let's say, for example, this is 30 degrees, we can find this angle because they're congruent. Opposite angles are congruent. And then we can find this angle here knowing that these two angles, consecutive angles, are supplementary. So that would be 150. And then again, opposite angles are congruent. So that is 150. Step 5. Let's look at the opposite sides of the parallelogram. With your compass or patty paper, compare the lengths of the opposite sides. We need to go back up to our parallelogram, L-O-V-E. And so go ahead and take your compass and put the stylus here and go ahead and open up your compass so it touches point O. And then I want you to go ahead and compare that. Oh, my battery's low, but we'll get that. Compare that to this. Should notice they're congruent. Do that again. Put your stylus on E. Open up your compass to swipe up to L. And then go ahead and compare that to segment OV. And you should again notice they're the same. So this is the opposite and sides conjecture. The opposite sides of a parallelogram are congruent. So let's take a look at this one last example before I move on to a second video. So ABCD is a parallelogram. The perimeter is 119. And we know that segment BC is 24. So I'm going to label that 24. Well, according to the conjecture I just wrote, segment AD is 24. And I'm looking for AB. And it turns out AB is also congruent to DC. So now I can write an equation, 2x plus 48 equals 119. So 2x is 71. And then divide by 2. X is going to be decimal. It's going to be 30.5. It doesn't give us a unit. So those are the first couple parallelogram conjectures, and we're going to start to find some other ones with some diagonals in the next video.